Good afternoon, everyone. This is Penny from Wisconsin Land and Water, and I am the Conservation Training and Membership Services Coordinator at Wisconsin Land and Water. Welcome to the Practice of Engineering webinar. Our first presenter is supposed to be Scott Miller, and he's having some technical difficulties, so I am waiting to hear back from him. But I'm going to go through a few things and get us started, and hopefully he checks back in and we can get his presentation ready to go. We have three presenters today, and the first one is supposed to be Scott Miller, and he's the NRCS Assistant State Conservation Engineer. And then Mary King's going to supposedly go next, and she's our NRCS Northwest Area Engineer. And then Pete is going to talk, and Pete is a DATCP environmental specialist. And then we're supposed to go back to Scott again at the end. And I just wanted to mention this webinar is also being presented by and provided by the State Interagency Training Committee, which is SITCOM. And that is a committee that we look at different trainings throughout the state, our needs and what we think you're looking for. But if you ever have any training suggestions, please send them to me or someone else on Sitcom or somebody else at Wisconsin Land and Water. We have a variety of ways that we can provide trainings through webinars or in-person trainings. And obviously we have the annual conference each March. And one of the trainings that I'm working on now is the managed grazing training, which is going to be held up in Marshfield, May 14th through the 16th. That's a 3-day training. SARE has offered a grant for that. So they're covering lodging, some of the meals, some of the travel expenses for some people. I think NRCS isn't eligible because it's a training grant that is also through NRCS, but that training is on the Wisconsin Land and Water website, and you can check it out there. I am still waiting to hear from Scott Miller. He is having technical difficulties. Mary, would you guys want to maybe get started first? Have you figured out if that can work for you guys?
Yes, we can start off. It will be a little awkward starting in the middle, but if you want to hand over the screen, I will bring up our PowerPoint.
Okay. Mary's going to be putting on her PowerPoint. She said, we're starting kind of in the middle, and we may be going back to Scott when he arrives or we hear something from him. But Mary, are you ready to go forward then?
Are you seeing our screen?
Yes, I am.
NEM 541.5?
Yep. We're ready to go.
Okay, so we're starting with what's called orientation, or otherwise known as, can the site be located from the location map on the cover page? Can the survey lines be relocated and the job staked for construction as designed? And are all dimensions and construction details clearly shown? So the purpose of the location map is to describe where the site is located to someone who has never been there. Traditionally, the location map shows the entire section and then points out where the site is located in that section. If you want to zoom into a quarter section, which quarter section should be noted in the township range and section area? I'm going to try turning on our little pointer here. So up here, you could say that you're the northwest quarter section or something like that. Maps should be drawn with the north arrow north toward the top of the sheet, but if this is not feasible, the map should be drawn with the north toward the left. A north arrow must be shown on all maps. Show an egress route when the site's not close to a road, and especially if it's not obvious how to get to the site. And label the roads. Ideally, there is more than one road, but items like rivers, we have a river here, and railroads can also help in location too. A quick checklist, if you're the checker of a plan for the location map, is can the farm be located from the plans, and is the project site clearly shown? Now, another, what we might have thought of as map, but they're calling layout drawings, or sometimes they're called plan views and layout sketches. The north arrow can be in any direction on these. You want to pick a direction that allows the layout to fit on the page. Traditionally, the layout would have the direction of flow going from left to right or from bottom to top. And then the north arrow would be important to show how to orient the page in the field. But if you're having it go left to right or north to south would make it confusing, you can have the north arrow going up, as is shown in this example. A quick checklist for a plan view includes, having benchmark information, some layout dimensions, a scale, and of course your north arrow. Vertical control requires picking good benchmarks that will last through construction. A good description or northing and eastings are needed so that the benchmark can be relocated during construction. In this particular case, these TBMs just said nail in a tree, and the construction plan actually got worked on 5 years after it was surveyed, and one tree couldn't be found anymore and the other was now a stump. So consider these things when you're doing your survey. Horizontal control, this plan view shows some riprap stationing, let's see here, clearing extents and a spoil disposal area. But is it describing horizontal control? The designer chose the downstream property line as station 10+00 because it is an easy to locate that point in the field, and it ties into some existing riprap here. This is an example of some good horizontal control. However, the spoil disposal limits, this black line here, was not well described. It's really only visual. And so the question to ask is this acceptable? Would it have been better to give a minimum distance from the top of the stream bank that's shown, and maybe just label the left edge as the field edge? You can kind of see that from the aerial photo that we have a change in vegetation, but it's kind of left it kind of nebulous there. The upstream end gives the starting riprap point as station 3+60. This can be measured from the 10+00 station, and it also allows for extension of riprap if you need to take it a little further during construction because of things that have changed in the site. And this way we wouldn't have any negative stations. If we had made this 0+00 and gone the other way, and then we had to extend in this direction, we'd now have some negative stations. The white dashed line indicates some clearing limits, and it was to allow access for construction. But how is this located? This site needed a permit because this area is a wetland, and it's important to disturb as little as possible. So to give better horizontal control, we probably should have a maximum dimension from the stream bank. Another side note is this stream bank actually moved 40 feet inward in the 5 years between survey and putting the plan together. So something to keep in mind on horizontal control. A common error in the preparation of construction drawings is actually the omission of required details, sections and dimensions. Soil boring locations. They're really only needed in the construction plan if it will be useful to the contractor to construct the practice. But what's important to note is soil logging information is always required in the soil report that's kept with your planning documentation. When it is included in the drawings, the boring logs should be plotted on the profiles or cross sections at the locations taken. And when the test site does not appear on the profile, the location may be identified on the location map, and then your log data can be put in another convenient spot on the drawings. The Unified Soil Classification System should be used to describe and log all soil materials. And applicable groundwater levels with the date of the observation should be shown on the logs. So profile locations. So profiles and cross sections, they both kind of fall under this topic, and Pete's going to get into profiles a little more. I'm going to discuss a cross section since there's one on this plan view. Cross sections should be plotted as viewed when looking in the direction of increasing stationing of the survey, such as from station 0 + 0, 0, and you're looking toward the next advancing station of like 10 + 0, 0. Stationing usually increases in the direction of flow toward the downstream. So you can see the flow direction is this way on the river. And in this situation, we had, you can see 3 + 0, 0 on this side and 8 + 90 on this side. So if we kind of turn our heads upside down and we're looking downstream, 0 would have been on our left and the higher stationing to our right. And so we often will say left to right looking downstream. But if such orientation makes the drawing unclear, it may be changed as long as the orientation is labeled, such as left to right looking upstream. So perhaps in this situation, it may have made sense to have 0 on the left because of how our plan view was showing. It depends what you're used to doing in your office. Also, if sometimes rivers are already stationed from a previous job, and then you should always go with what's already being used. But when you do your stationing, how do you locate the beginning and end of the cross section? Rivers tend to meander, so a fixed location at one end of the cross section would make it easy to plot your as-built cross section over the original. Whereas if you had just used, oh, here was the side of our slope and now our slope has actually moved 40 feet, you might not be putting things on top of each other in that same cross section. So another question to ask is the cross section needed to construct the project? Maybe. Is it just a design tool? In this situation, the full cross section from 0 + 0, 0 all the way to 890 was used in design, but for the construction plan, we probably could have got away with just starting at the center of the river and going toward the slope that we were riprap-wrapping. In that case, your cross section on your plan view should start at the point that you're using. In this case, the plan view is only showing from 300 to 8 + 90, so the cross section in the plans should show those same stationing. Multiple cross sections on a sheet should be of similar scale and arranged sequentially and according to stationing. And probably the main point is consistency. Orientation of views and directions of stationing must be consistent throughout the drawing set. Now I'm going to give the headset to Pete because his slides start now.
All right. What I was going to talk about today was the style and content that we put in our construction plans and details. Starting out a little bit dry because we'll talk about some of the National Engineering Manual policy, but the policy, written policy, is where we keep our consistency, the things we do, and that's where a lot of the information that we're after is found when you're looking at construction plans. So starting out in the NEM, says drawings should present as much related information as reasonable on the same sheet for efficiency and clarity. If possible, details should be drawn on the same sheet as the work to which they apply, so you're not chasing through a plan for different details. If details are shown on a separate sheet, appropriate sheet references should be noted. So try to get it on the same sheet if you can, but if you can't, you can note to different sheets. Dimensions and sizes of components should be shown on the drawings rather than referenced in specifications or standards. Reduce the number of pages where possible. If you've been around a while, you may have seen the 25 or 30 page set of construction plans, and it's hard enough for us to deal with that, but a landowner or contractor would be even worse. So try to keep page numbers down. But if the page size is limited, you can reference some of the details to other sheets. Now here's an older drawing example with multiple details on one sheet. Now this was one of the bigger size sheets, and we tend to get away from those nowadays, but because you get out on a construction site, it might turn into a kite or something because they're so big, but they did have a good use in that you had the multiple details all shown. Your individual printer capabilities and paper sizes are going to dictate the amount of detail you have on a sheet. Now, most of the time we go with the 11 by 17 nowadays. Here's a more basic view with notes indicating which pages the additional details are on because you couldn't fit that many details on there. So you can see sheets 9 and 10 for additional details and that type of thing. So notice that the dimensions are shown on a drawing. What you don't want to do is have a reference, say, to a standard to get the top widths, like see the 378 pond standard for the required top width. You want to have it on your plan so that all the information needed to build a project is pretty much on your plan view page, or at least you'll know where to look for it. So here you can see the grass waterway standard drawing details are referenced by page number. Again, it's C sheet such and such for the details. And in this case, a photo is brought in behind the survey data, and that can be a good visual aid, but it's not required. In some cases, it's not really that helpful. You'll notice up in the upper right here that you have a road name that's being a little bit hard to see because of the background information and colors behind it. So the style and content we've talked about. Content, appearance, and the details themselves are all extremely important to us. We should take pride in our work and strive for complete clarity in what we're showing. For consistency, we follow industry and agency standards so that across the state, the things are pretty much the same. Symbols used in the preparation of maps and engineering plans should be consistent with the national cartographic mapping symbols. So there are national symbols out there. Our construction plans and drawings need to have a professional appearance that we can take pride in. Mistakes and sloppiness in our details are not often forgotten by contractors and landowners, if they ever forget. I mean, if you give them something that's of low quality and they find mistakes, they aren't going to forget that. So we strive for clarity and a professional look, and some cases it's almost like a work of art that we can create something that's really good looking for them. So our construction plans are all fairly similar, and that's for a good reason. We're following the industry and agency standards. We all start with a cover sheet describing the geographic location of the project. We also always include quantities and pertinent Wisconsin construction specifications. It's important to get the page numbers right. That seems to be a recurring problem. And with today's CAD drawings, layout pages are often scavenged from other plans, which is a good time saver to take a page from a different plan and bring it into your plan you're working on. But we have to be real careful with that and make sure that we keep the exact details we want for the particular project we're working on in our plan. I've seen cases where the estimate of quantities page came into the plan and there's a wrong pipe size, and all through the rest of the plan you had a 12-inch pipe, but on the plan estimated quantity sheet you had an 8-inch pipe size because it was brought from a different plan, and that was very difficult for the contractor. So we take pride in accuracy in a set of plans that is easy to read. We're often going to show details that we create in the plans, various views of the project components. You might say, well, which details should I show? And this is a big one here. Our construction plan content is shown at the back of the design standards that we're using. There's a list of plans and plan requirements at the back of the standards. And it's really critical that we look at that and we include everything that's in there. That's going to keep us consistent, and that's the requirement. I mean, you have to meet the design standards. So, and don't think that your quality assurance engineering spot checker won't be looking at that list when it comes time for the engineering spot check. So keep in mind that the list is our minimums too, though. You may have to add additional details. Our goal is to show the views of the details of the various conservation practice components required for easy comprehension of the project by landowners and contractors. We often assume that landowners and contractors understand our plans, but all too often they do not, due to poor plan compilation and explanations by us. In some cases, landowners are actually very surprised by the end result of our practice applications, which is really unacceptable to us. I've put in barnyard projects, and the landowner said he really liked the project and the end result, but he said he was surprised at how it looked, and I couldn't quite understand how that was. But we have to be careful because it's almost like we're speaking our own language with a lot of these projects, and we're very familiar with the drawings and details. Contractors probably are too, but the landowners may not be. So to be clear with our plans is a very important thing. Good details and even photographs can be incorporated into our designs to help communicate the details. So you're seeing more and more of the photographs. We should take pride in the clarity and accuracy of our work. We often include standard detailed drawings taken from the Wisconsin NRCS website. Standard detailed drawings are very helpful and make our lives easier. A lot easier, actually. If you're planning to modify or customize a standard detail drawing, you'll need to take the standard drawing number off the page or else relabel it as modified. It is highly recommended that you make the changes obvious. So here you can see where it says modified. And the changes are up here. You want to somehow make it obvious with your text or text color so that the checker can see what you've changed, so that they don't have to guess at how the drawing has been modified. Structural component changes need to be approved by someone with proper engineering job approval authority. So be careful when you're changing a drawing. It's your responsibility as design approvers, if you're approving the design, to ensure that the details result in a practice that meets the design standard requirements from the field office technical guide. So you're ultimately responsible that that design meets the standards. So you shouldn't be willy-nilly changing the standard drawings if there's any question. The symbols we use on plan views should be uniform from project to project. And because of this, they've created helpful standard drawings with symbols that we can use that are up on the website. These drawings can be used, or else the same symbols that are on the drawings can be shown on a page view or layout sketch in a legend. And it might be preferable to have it in a legend so you don't have additional pages in your plan. But the legend and symbols help reduce the need for leader lines and notes, which could clutter up your views. Symbols used in the preparation of maps and engineering plans should be consistent with the national cartographic mapping symbols. And the ones on these drawings are. So scales for drawings should be selected carefully to assure clarity of details and accommodate reduced size reproductions. Bar scales are preferred for maps and plan views and are necessary for any drawings that will be reduced for printing. The scales used are always important. Can an old person like myself read the dimensions and letters in the field without a magnifying glass? Can you tell what the details represent? Will reproductions result in readable plans? These are all things you should be thinking about. Archived EFH Chapter 5 indicates the standard scales we can use for topographic details. Easy scales for field use include 1 inch equals 20, 40, 50, 100, or 200 feet. EFH Chapter 5 information is older and it relates to the standard drawing sheets we used in the past for design, but they are still relevant today for clear and easy to read plan views and profiles. Keep in mind the field work and units on your engineering scale or ruler that you will be using in the field for layout. Using a scale that would require conversion of the units on your measuring tool in the field is not a good idea. I think I've seen scales used that the units on the scale were that you'd measure with in the field were like 1 unit equals 2.5 feet, and that made things difficult. So try to keep things as simple as you can. Your goal is a clear and easy to read depiction of the project that is simple to use and accurate tool for project layout. Text needs to be readable. Handwritten uppercase should be 3/20 of an inch high and lowercase text 1/10 of an inch for easy readability. Computer-aided drafting text size can be smaller, but because it is easy to read. Use the template sizes for consistency. The templates are up on the NRCS website. Avoid different size text on the same page. Note the bar scale that keeps accuracy when reproductions are made of this layout sketch right there. Keep the text size clear and readable. Our goal is complete clarity of the details, making them easy to see, read, and lay out in the field. Note the fixed known points with stations at the roads, building, and reception tank. What you don't want to do is send a plan out with a wonderful detail you've created and then not have any fixed dimensioning on it, like make the person use an engineering scale to measure to the practice. You want to have things laid out with dimensioning, or else the cross sections or profile stationing so that it can be located from either fixed points, or in some cases we'll use the GPS units with northing and easting to locate corners and things like that. But we need to be able to locate these things. That should be one of the priority things you're thinking about when you're designing and putting your plan views together. Clear and easy to read and understand views are the goal. Don't sacrifice clarity in order to fit more on a page. Pick a scale that makes sense for the size of the conservation practice and the sheet size you're using. Notice the legend in the lower left. That's the same as the National Cartographic Scales, should be. Avoid different text sizes. Consult with a CAD specialist to make this process more simple. You can see some of these are bigger, some are smaller. Try to keep that consistent. Profile scales need to be reasonable and readable. Using AutoCAD, most profiles turn out well as long as we pick good vertical and horizontal scales that fit on the paper. Notes are usually included on the profiles to clarify things. Keep in mind that profiles completed according to the standard convention show flows and grades from left to right. Profile page view scales are not critical since the units are clearly shown on the X and Y axes, and the vertical and horizontal scale will usually vary. You're not going to have a bar graph on a profile view. Note that the vertical scale shown divides in foot intervals. Therefore, the elevation to the nearest tenth is notated at the grade changes. Avoid extremely long profiles on a single page, which causes the actual details to be minute. You can include distortion in the profile, and should if a 1-to-1 scale is too long or too high to fit well in your drawing environment. Profiles and cross sections can be shown on the same page. Here's a profile of a manure transfer pipe and 2 manure storage cross sections. There are plenty of notes for clarity. Note that there could be improvement with the text size consistency. The scales can vary between profiles from plan to plan, but try to keep the scales similar within your plan on your cross sections, if you have several of those, and on your profiles, because a person can think they're using a certain scale based on one profile, go to the very next one in your plan, and if it's a different scale, it can be confusing. Note that there could be improvement with text size consistency on this view. Structural drawings like standard reinforced concrete wall drawings use an architectural scale of feet and inches. All other scales are feet and tenths. So your standard drawings are a little different. Now about the notes, notes should be precise and to the point without a lot of repeated notes to clutter up the drawings. You don't have to keep repeating things. And in fact, too many notes will actually reduce the impact of each individual note. They'll just get lost in this huge amount of notes in the plan, and they won't be zeroing in on things. The specifications can be referenced or items emphasized by taking the words right out of the specifications. And that's for emphasis. Don't keep repeating the specs in the plan, but keep things clear and uncluttered. Avoid writing the specifications word for word on your construction plans, but you can mention critical items for reinforcement. And make sure the text line weight is readable and can be reproduced easily. So actually, that's all I had.
Okay, this is Penny. And we actually have, so if some of you maybe have tuned in late, we had some technical difficulties with Scott Miller, who was supposed to start us off and give the lead in, and he wasn't able to join us, but he is now joining us. And just a reminder for everybody, you can unmute yourself at any time to ask questions, or in the chat line, send us something to everyone. It looks like we're back to Scott. Are you there, Scott?
Well, I've been on the line listening and following along, so I've been here. I am ready to go, I do believe. Thanks for taking an hour or so to listen to us. We are going to talk a fair amount of policy and law and things like that, which was what I hoped to start with to give a framework for what Mary and Pete worked on. But here we go. So all of this starts, the practice of engineering and our engineering job approval all starts with state law. So in Wisconsin, we have a state statute, chapter 443, which is the examining board for a bunch of people and professional engineers and designers and other things as well. So it's where you get your license from from the licensing board. For the section with professional engineers, these are actually clipped right out of the statute. So they define the practice of professional engineering, and it is very, very broad. It's providing professional services, applying engineering principles, and note the next underlying pieces, things as consultation, investigations, evaluations, planning, design, and supervision of construction. Kind of what we do, right? So that's how why we have the job approval system that we can fit into this, and we'll go into that a little bit more. You know, unless you are licensed as a practicing professional engineer, it's really illegal to represent yourself as being one, as that bottom statement talks about. It goes on in the law that you can't practice, as I just said, unless there's a number of things. There are a bunch of exemptions. First one, you're registered. Second of all, exempt under 443.14 or 0.101D. And with those exemptions, if you're working under them, you are okay because you're exempt from being licensed as a professional engineer. And those exemptions are what you see here. It's the federal employees working for the federal government, and it's also what most of us know as the certification program through the Department of Ag. It exempts us from being registered as professional engineers. It doesn't exempt us from using good practice of professional engineering. And we do this through our, through NRCS at least, through our National Engineering Manual, and we'll get into that a little bit. But a broad topic here, which was going to cover Mary and Pete's part, is a philosophy of the practice of engineering. That we want to put enough design documentation together in all of our efforts that we tell the story of that design process and it's clearly presented to others. We do a decent job putting design documentation together, but we don't do sometimes is connecting the dots of all the pieces. And a reviewer and approver, at times when you're looking at it, you have to make some assumptions or do interpretations of reports, where as a designer, you want to lead them to make the connections and don't make the reviewers and approvers reconstruct things that you've done on scratch paper, side notes, in your head, on your computer. It needs to be part of that record. And that's the design process. The construction plans and specs, which Mary and Pete covered, are conveying that to the builder of the project. The operation and maintenance things are for the landowners to operate that system. And with the other document we present, the inspection plan, the quality assurance plan, is the designer communicating to the person who's going to be the boots on the ground on what types of information they need back to make sure this was done correctly. So one of my last slides is going to be the proper document for the proper people. So that's tying it back together with this philosophy. As I mentioned, we have the job approval system, which helps us be exempt from the state law. In the National Engineering Manual, that is spelled out in Part 501. We have other sections we follow, 510, 511, 512. And you heard a little bit of the 541, the drafting and drawing piece as well. So one of the things we want to do is, how do we pull all this information together? We should have a good design folder, and it's going to be appropriate to the job. Having a grass waterway or a simple diversion is not the same design folder as a complex ag waste system, a complex irrigation system. So all of these pieces may or may not be there depending on your job, and they may be just a sentence or two or a few notes on your computation paper compared to a long 3-ring binder report. So remember, it's got some scalability. So the first box there is the design process. You know, the working through trip notes, survey notes, soil investigations, all of that upfront information. The next bullets are more design related. And on the right side, more design related information. And the bottom part, the reason for the line is, now we just transitioned from design documentation to construction drawings and material for others. we often think of, oh, we just need to improve the construction plans. Well, it's the whole package, and they are distinct, different documents, and we need to consciously remember that. Okay, so I'm going to step through planning, design, and construction briefly out of the NEM. Again, the scope and complexity is going to vary, but we want to do the early planning things. We've talked about conceptual plans and preliminary soil investigations. We want to do those so we don't have to duplicate it later. So you can see some notes that are pulled right out of the NEM on how to do, or the guidance to do that, and why we do those things. And remember, scalability from small to large here. A little bit more on the planning. We do them, but it's putting them together in small, simple packages. So if somebody said, oh, I'd like your soil report, that you have all the soils information together in a packet. I'd like the design documentation when we get to that point, or some of your trip notes. Nice small packages that you build along the way as we build our more complex projects. Again, size and complexity and level of detail, it depends on what we're building. Okay, design. Once we have all our planning done, and the reason it says final design is there are different stages of design too, of preliminary and intermediate stage. For those of you who are familiar with the private world, you know, they talk about 20% packages, 50% packages. You know, this is the 90 or 100% package with final design. We want to, in that final design, go back one last time and make sure that everything leading up to this point documents and carries through to our final design. There are times when that doesn't happen, so we need to go back and check the entire design folder when you are the approver of the design itself. Make revisions of preliminary stuff that we need to along the way. Double check the hydrology, double check the structural comps, and start preparing the things moving out for the contractor. When you finish your design, that's the time to go and write your design report. It's a summary. Think of the executive summary of a document. You know, give me those 4 or 5 pages to give me the cliff notes of what I'm going to be looking at as the reviewer and final approver, with details to follow. Completing the O&M and the quality assurance plan as the last pieces of the design process. Okay, in the design, it talks a little bit more about construction drawings and specs. It refers you to other places in the NEM. But those first 3 bullet points, if you pull it up in the NEM, are one big long sentence. I pulled them apart to just add some clarity. Again, it's the final step. It's the graphical representation of the construction plans. The specs are the narrative. They need to connect. They need to provide enough detail to get a quality product built, and it clearly, states the requirements. All of this information needs to be in the construction plans. It can't be on our computers, on our data collectors, in our heads. It needs to be communicated on those construction plans. So this was the part of drawings. This is the general information, and Mary and Pete followed up with more specifics, but this is the general stuff that was leading into their presentations. Again, communication. It is all about communicating it to the right audiences. Pete did a wonderful job of summarizing this. Limited notes, limited to those for accuracy. Too many notes, repeating the entire specs in the notes, then why do we have specifications? We need our contractors to know our specs as well. Calling out a few details to reinforce it is good, but if we put it all there, as Pete said, just takes away from the few notes that we do need. Drawings including soils information. Is that information going to be important for the contractor actually building the project? You know, if they are just excavating a hole down to some subgrade elevation and then building upon it, they don't necessarily need to have the soils information if it's not making the construction difficult for them. Because all they're doing is doing the excavating. The showing of subliners and liners and those things are for our purposes, and those need to be in the design side and not necessarily on the construction drawing side. So keep that in mind as putting things together. We need to have our benchmarks, datums, and those things on our construction plans so that others can lay them out. The more we are having, especially as NRCS, having our partners, Ducks Unlimited, Trout Unlimited, other contractors that we hire out to do things, we need to have those things on the drawings, because it's not, as Pete said, when you're an old guy and can't read them, I'm going to say it's not an old guy like I am, where we were the ones doing it from start to finish. That may not be the case. We need to get those things on the drawings, especially if we need to come back 10 years later, 15 years later. I know my memory won't be that good anymore, so having it there on the drawings is going to be very helpful. Okay, if we pull up our NEM policy, what I was just going through is the national policy. JR, when he was putting together the supplements for Wisconsin, included these items for construction drawings in our Wisconsin supplement. And it's a lot of what Mary and Pete talked about along the way. Note the 1, 2, 3, 4, 5th bullet, what we were just talking about. You know, our contractors are getting more sophisticated. They have different capabilities. You know, so we can do the GPS layout, but we just need to have it on the drawings compared to 500 feet from this stake and 200 feet from that corner of a building. We just need to be able to get it literally from the construction plan onto the ground, however that is going to be, because if it moved, we want to be able to redline the locations, not graphically, but also how it was laid out as well. Next bullet down, checkers and reviewers. There is policy that all of those pages are checked, that you as a checker, reviewer, approver are touching those pages, not just to touch them, but to make sure that they are of high quality and represent our agencies that we work for as well. This last bullet is important, as I was mentioning about layout. Think about what you need for an as-built when you're done, and think about having that piece of information. Oh, I want a cross-section here, so I'm going to put that in my construction plan because I want an as-built of that. I've seen construction plans where I get 50 cross-sections of waterways every 100 feet or so because CAD can spit it out. To me, that's telling me you want 50 as-built cross sections. I'm not sure you want that. I think you just want 1 or 2 typical cross sections that show that it meets the standards in the drawings. So think about as you're putting that together and and what you put in there for detail. Sometimes we have the exact detail of what we want out of CAD, but we also put in the standard generic cross sections and things. Do we need both? I would argue not necessarily, not all the time. So be conscious of what you want as built and when you're done as you are putting together your construction plans. So checking of construction plans and all of that, you don't necessarily have to have job approval to do these. You just need to be experienced, have a good understanding of the concepts and the procedures that are going to be used. It's a very good way of gaining job approval for systems. And it is not just initialing each page because we have to. We really want you to go through and double check. I know I don't catch my own mistakes as I'm writing things or designing things. Having another pair of eyes is very helpful to do that. So all of the math, the consistency from sheets to sheets, as Pete was mentioning, does it translate from the design into the drawings? Are we saying the same thing? There is policy in Wisconsin about which levels of jobs and what level of checking needs to be done. If we have class 1 or 2 jobs, not as critical, that aren't ag waste management, it's possible to check your own work. I wouldn't do it the same day I'm designing it or hours after I'm designing it. And you need to remember to not just check the box, but also go, okay, step back and really look at it with a fresh pair of eyes. When we get up to the higher level practices and all the waste management practices, we want a separate pair of eyes to make sure that when we're dealing with the health and safety and welfare of the public, that we're doing a little better job with our checking and reviewing. So the checker is going to be somebody different, and those 3 bullet points there are talking about the final approver on who or how that is done. Okay, so back to the design folder. I had this slide broken in a conglomerate before, but in our design folders, keep them orderly and keep them current. And here are that same list of things we would want to have in them. I've heard stories, I've seen it, of, you have 2 or 3 options, landowner changed his mind, that are just all together with everything. If you need to keep them, drive a big staple through them, put them in the back as an appendix as option 1, option 2, whatever, but keep the current design and logic and thinking all as a packet in a very orderly form. Continuing on with that list, same thing as I had before with the space in here with construction drawings, starting the construction process, plan prep compared to the design piece of it. One note I'd add here, with design tool printouts and things like that, where we're generating them with other means. Back when I was a pup, we did it all by, maybe not all by hand, but close. And we wrote things out, and we stated our references we use. Oh, we pulled this out of EFH table or chapter 7, table 8. And here are the results of that table. Well, when we can just print that and attach it as the next document in our page, in our design folder, that's helpful and good. And I have all of these lined up behind it. But it's helpful to have that summary of stepping through that, page 2 is the printout of the allowable velocities or the size of the manure storage. And that there is the final check. You have if you think of a legal document, whereas this, whereas that, and therefore, having that therefore statement of the design volume is this, and we're exceeding it with our constructed volume of this amount, to be very specific with that to help your reviewers and approvers go, yep, got it. They can almost put a check mark next to it of, yep, that makes sense, and move down the page. So that'll help us get better design folders and design computations that lead to our construction plans. So here's where I did it again, where Mary and Pete would have jumped in with their presentation of construction drawings and how to put them together in good practice to do that. So,
you want me to do it again, or?
I think it'd be a good idea, Pete. No, you guys did a wonderful job. I add this slide here because, as Pete mentioned, in the standards, there is a spot of plans and specs and operation and maintenance. And as Pete said, those types of things should be in our construction plan. Our national office is modifying and changing the conservation standard practice document template. And this is what's supposed to be in those sections. And it hasn't changed the whole lot. But the part that's not written here is that we, a state now will have the option to modify this compared to what we had. And I think as a state, we need to take advantage of that opportunity, because sometimes there's a big, long bulleted list, and you look at the typical projects in our state and you go, why would we want to add that here? Because, of our rationale we would use. So we're going to have the ability to do that now, compared to what we had in the past as we adopted our Wisconsin standard. So just a heads up for the future. Okay, we got our construction plans done and whatever, and ready to go to the landowner. And landowner signatures is part of our 501 policy, that we would want to see them, that the landowner is accepting that construction plan. There is an acceptance statement on one of our standard drawings, and I'll get to what that statement is here in a little bit. It follows 2 slides back here. But you can see it on a standard drawing. It's on our Wisconsin 001C. Everybody wanted to have it back there instead of having this separate landowner statement job sheet, which opened up our cover pages of our drawings, but it also put this in another document which needed to be tracked. And how do you connect them? Yes, there's good and bad both ways, but that statement looks like this. They've looked at it. They agree with this. They want to follow it, because if they don't, it may jeopardize technical assistance or financial assistance. They're to get the permits, and when I modify this with my contractor, I need to make sure that the designers are aware of that and approve of it before we go that. And they're also going to hire the contractor. Okay, all built, ready to go. Now what do we do for as-builts? One thing to remember is, just having, the numbers there, just like our design side, we want to know how they were obtained so it can be reproduced if need be. So as you're doing your job diaries, your survey notes, you know, as you're doing the checkout of practices, you know, note how you are getting it. So if it's a grass waterway, is it a GPS, survey grade GPS? You're getting top and bottom, and that's how you came up with your length. Or is it wheeled? Or is it off an aerial photograph and then confirmed in the field that that's the amount that was there? You know, just note how it was done. Again, more reproducibility for others along the process. So here's that slide again of pulling everything back together. You got the first part of your design folder, the blue boxes. The below the line on the right side is the what do we give to others to do. Everything prior to that is almost all internal for our design folders. And then lastly, the as-built, the red line. Notice the red outline. So all of that, when we get done with a project, neatly organized in our construction design or in our design folders for the job. So we have a document in NRCS called Technical Reef number 62, and it's our surveying information. I know a lot of people have not seen this, but we've heard about it and people talk to us. But the difference, you know, accuracy is important. How accurate do you need to be with a dimension or an elevation or a coordinate as you are presenting it to someone else? Because it means different things to different people. If I have a number that is 0.05, I want to make sure I have a 0 out in front of that, 0.05. It just makes it easier to read for others. And it also needs to show the level of significant digits that you are looking for. Typically, our earthwork is going to be to the nearest 1/10 of a foot, because you're not going to use construction equipment to get it any closer than that. But if you have 0.7, you'd want to see it near 0.7. You don't want it 0.9, because you're looking for that amount of accuracy. If you have things that are stated to the 100th of a foot, that's the expectation you are sending forward when you are presenting that. For most of our stuff, nearest 1/10 of a foot is going to be very close enough and function just fine. If I have a layout coordinate as I have it shown here, northing 100.257, easting 500.125, and an elevation to the thousandths, that's the expectation you are giving when you set that. So as your as-built, doing your as-built or doing your layout, are you looking for that kind of accuracy? I'm guessing not. Yes, you could go in and edit the table and whatever to make that, you know, as you spit it out of CAD. That takes a lot of work and extra effort. We don't need a note on the bottom of northing and eastings to the nearest 1/2 foot, elevations to the nearest 1/10. That would be perfectly acceptable to relay the expectation you have that you are putting in your construction plan. Okay, one last slide here. I mentioned early on that I'm going to wrap up, or had planned on wrapping up, having the right document for the right audience. When I was putting this together, I thought of, oh, we'll have a quiz at the end and have people chime in and figure out and put them in the right categories. And I decided against that. But think about the documents we talked about and are creating through this presentation, and then think about the audiences on the right side, and think about where they mesh. there's some overlap, but there are certain documents that, definitely are for a particular audience. And think about that audience as you're developing and putting that document together, because it's going to help you limit and make that document as it clearly communicating the information you wanted to communicate. So any questions as we wrap up for the day?
Bernie has on there.
I see one.
You see that?
Are there available checklists for the checkers? We don't have those. I know people have them out there and they use them for their projects. The problem with checklists are always that the only thing you check or is the expectation you're putting out when you have a checklist is those are the only things to check. What happens if there's one more item or it's not important to this job? So I understand why they're helpful, but on the other hand, we want to have our designers be thinking through what needs to be there and our checkers verifying that that's what needs to be there. So short answer to your question is, Bernie, no, we don't have them. The standard is a good place to start of, do I have that? But it is more than the standard. Just meaning the standard sometimes isn't enough to practice engineering. There's a whole lot of design and thinking that we need to put into that beyond what's in this written in black, my old days, of black and yellow in the standards. Any other questions people have? If not, I see Penny, you have a item there for a short evaluation.
Yes, if people could go to that link, that would be nice. It's just really short, just a couple of quick questions that we would like to do about the webinar. Also, someone emailed me. We are recording this webinar, but if somebody wants just a copy of the presentation slides from today's PowerPoints separately, I don't know if we'll post those on our website. We will post this recorded webinar, but we will also have the slides available for people upon request. Well, thanks everyone for bearing with us, and glad Scott was able to join us and get his screen working for us. And Mary and Pete, thanks so much for stepping in for us. And I'm just looking, no other questions are coming in. If you ever have any training requests or ideas, we can pretty easily do webinars. They usually work pretty well. Every once in a while we have a little glitch, but we usually come through in the end. DATCP provides us some training funds that we can do other trainings as well, in-person ones. So if you have some ideas, shoot them my way. I'm always open to new suggestions. Otherwise, I think, are you guys done out there? Think we can say goodbye for the day?
I am done.
Okay, have a great day. Thanks, everyone.